see these are the people who are in my math class. I should be in my math class. Well, I'm in my math class.
There you go. So maybe context clues would help with that. Okay, let's go over the quick tech. There were two different ways you could have done this. One by finding your intercepts, one by finding the slope-intercept form. So I'll do both. If I tap it a lot, it'll work. Okay, so we'll do intercepts first. If I was doing what we did last class, covering up one term, I get 3x equals 8 and 4y equals 8. So I could solve both of them. Divide by 3. If this is not what you did, it's okay. This is just one way you could have done this. You would get a fraction, or as a decimal, it's like 2.6 repeating. For the y, you would get 2. And you would plot those 2 points. So 1 at 2, 1 at 2.6, so like between 2 and 3, closer to 3, kind of in the middle. And draw a line through those 2 points. If you were graphing by intercepts. Or you could have solved it to get your slope-intercept form. So if I was doing that, I would get rid of the 3x, subtract it on both sides. Switch these two and divide everything by 4. So we get y equals negative 3 over 4x plus. Still going to start at the same y value, but now I can use my slope points. Go up 3 to the left 4 as many times as possible. So the one with the more points gives us more to graph and it's more accurate. The intercepts, you could graph it and just have the 2 points, but your line may not be as accurate as straight because you don't have as many points. Questions on either of those? Now we're going to talk about the last thing we need to do before your quiz on Friday, test on Tuesday, which is intercepts. So it'll be kind of what we talked about last class, but a little bit more in depth, and from a graph. So everyone look at the intercept notes. Go ahead and close computers, iPads. So you guys have these definitions. I'm going to read through them, and then we're going to actually practice this. So graphically, on a graph, if I'm looking for the x-intercept or the y-intercept, that's where it crosses or touches the x or y axis, or intersects it. Algebraically, so this is kind of what we were doing when we were graphing by intercepts. The cover-up piece, this why this works. If we are solving for the x-intercept, y is 0. And if we're solving algebraically for the y-intercept, x is 0. So we're going to deal with that here in a bit. When we, in class, write our intercepts, they're going to be written as ordered pairs. When you do it on Delta Math, it'll just be the number, but we'll talk about that. And then you may see different words for x-intercepts. They're also known as roots, as solutions, and as zeros. So all of those words are interchangeable. Roots, solutions, zeros, x-intercepts. Okay. We're going to look at the graphs now. So we're going to look at, for number 1, where does this line cross the x-axis? At what point? 2. So I would write that in parentheses, 2, 0. Then, where does this line cross the y-axis? -3. So we would write that 0, -3. Questions so far? Okay, let's try on number 2. What are the x-intercepts there? There are multiple. 2 is one of them. Where's the other one? -4. So we would write that as -4, 0 and 2, 0. What about the y-intercept? You look at mine or look at yours. Yours would probably be closer. 8. Mm-hmm. I would write that as 0, 8. Find the x and y intercepts of number 3. What are those x and y intercepts? 5 and -5 for the x or for the y? For the x. How would I write that? 0 and parentheses -5, 0. Okay, what about the y intercepts? 5. 0, 5, and then 0, -5. Good. Look at numbers 4, 5, and 6. Which of those do we want to see, go over, have questions about? Have questions on any of those? If not, let's move on to the next page. So that was finding intercepts from a graph. You should be able to find where it crosses the x or y axis. Algebraically by hand, I'm going to show you 2 different methods, one in slope-intercept form, one in standard form. So the steps are off to the side. For the x-intercept, set the y equal to 0. For the y-intercept, set the x equal to 0. So in this equation, this f of x is the same thing as y. So if you want to rewrite it as y equals, you can do that. And then let's find the y-intercept first. So if I'm finding the y-intercept, we're going to set x equal to 0. Put 0 in for x. With parentheses. And then I'm going to simplify. 4 times 0 would give me 0. And then I could simplify this. 0 minus 8 would just be -8. So that would be, if I was just writing the number, that would be my answer. If I'm writing it as an ordered pair, I'm going to look at, I put 0 in for x, that in for y, so that would be 0, comma, negative b. Now, because this is in slope-intercept form, we really didn't need to solve for y. It's given to us. If we look at that last number, that'll tell us what our y-intercept every single time. But for the x-intercept, we'd have to solve for it. So then I'm going to rewrite the equation y equals 4x minus 8. And then put 0 in for y instead of x. And then we're going to solve for x. How would we do that? Say that again, sorry. Yes, add 8. And then divide by 4. So we get 2. Or if I was writing that as an ordered pair, what would that look like? 2, comma 0. What questions do we have on that process so far? We're going to do another one. Now, what we did for the y, we're not going to do that again because we can just look at that last number and we'd be able to figure out our y-intercept. So if I'm saying this is my y-intercept, how would I write that as an order pair? So not 1, 2, but it's going to be 0 first and then 2. Yes. So we can get that, if it's in slope-intercept form, get to y-intercept as is. We don't have to solve for it. But the x, we do have to solve for it. I'm going to rewrite as y equals put 0 in for y and solve for x. By doing what? Subtracting the 2. And then dividing so that x equals -1. And we would write that as an ordered pair. What would that look like? -1. -1, 0. Good. Questions about that?
It's not more easy to just divide the number 2.
For this one? Yeah. So if I were to divide, like before we subtracted, if I divided, I'd have to divide everything, and then I'd still have to move it. So that wouldn't really help us. I'll show you more. If I divided everything by 2, then we have 0 equals x plus 1. I still have to get rid of that 1, no matter what. Did you have a question? Alright, look at numbers 3, 4, 5, and 6. Do we have any of those we want to see, do, go over, have questions about? 5. 4. Those are similar, but that's fine. Okay, so for the y-intercept, what is that and how would I write that as an order pair? Zero, what was the last one? brackets. Look at that last number to get that value. And then I'm going to not rewrite the y, but just jump into where I rewrote the 0 to solve for x. So 0 equals 2/3 x minus 6. And then to solve for x, we would add what number? Yes. Yes. Then here we would normally divide, but we don't want to divide the fraction. That gets messy. So we're going to take that and flip it. So it's 3/2, and we're going to multiply that on both sides. In your calculators, multiply 3/2 and 6. So anytime you have a fraction, instead of dividing it, this is the same thing as dividing the fraction. Taking the fraction, flipping it, multiplying on both sides. Multiply on both sides. But this cancels.
Oh, okay. Okay.
What would that number be? 3/2 times 6. Say it again. 9. Yes. So we would write that as 9, 0. Questions on that? 5 is going to be done the same way. And then I'm going to show you how to do this in Desmos, graphing, double checking, and then we'll move on to one other type. And then you'll be practicing. So for the y-intercept of number 5, I don't know why I said negative. Yes. Okay. For the x-intercept, if I rewrite this, 0 equals 1/2 x plus 2. Get rid of the 2. And then just like what we did in 4, take that 1/2, flip it, and multiply on both sides. So that the 1/2 and the 2 cancel. What is x? It's 2 times negative 2. You still need your calculator, so I would go this. Okay. What did you get? 4, but negative 1. So if you wanted to double check yourself, you could put the equation, whatever you have, into Desmos and it will graph it for you. A lot of these ones are not going to be ones that we are quizzing and testing on because some of these are not linear, like lines. Most of ours are going to be lines. But just so you see what happens, I'm going to put this into Desmos. So when you put this in, so this one happens to be this U shape. We'll talk about that later. When you click on the function, at least 3 points appear. Your x-intercepts, if there are multiple, and the y-intercepts, and you just click those, and you can easily see what those are. So that works for lines as well. Okay, go on to the next page. or the back of. Yep, whichever one. Okay. So this is going to be similar to what we did last class, but also what we just did. So the algebraic piece of it, not just covering up and saying we got the other part. So if we were finding the x and y intercepts here, we have to remember if we're solving for x, put 0 in for y and vice versa. So same thing. So let's say I'm solving for y for this one. I would rewrite this. 8x plus 3, put 0 in for y. And I would solve. Well, this would be 0. I could really drop the 0. I don't need it. Or from here, I could divide both sides by 8. So the x is 3. And we would write that as an order pair 3, 0. I'm actually going to write that on this side. Then we would do the same thing for y, but put 0 in for x. So this is what we were doing when we were covering up the term, putting 0 in, that's why it disappeared. So if I were to divide both sides by 3, y is 8. Now, they're not always opposites, but sometimes they are. It depends on the function. Okay. Questions on that? We're going to do that one more time, but I'm going to skip. No, I did about the same side. So I want you to still put 0 in so that I can see that you're starting the algebraic process. But then you can just divide as I did. So for number 2, let's say I was getting x by itself first. It doesn't matter which one you do first. Because y is not multiplying to anything else, I can just put 0. But then I can go ahead and divide both sides by 4. Now we would write that as an order pair, which would be 2, 0. And then if I were to put 0 in for x, that would be 0. We don't have to put that part. We could just go on to leaving y equals 8, which would be my y-intercept at 0, 8. Look at the rest of this page, 3 through 10. Are there any of those we want to see, do, go over, have questions about?
Numbers.
Okay, we're going to do 5 and 6 actually. Any others? Okay. So, for number 5, this is my x-intercept. I don't have to do any work. It's given to me. I would just write that as an order. Done. For that part. For the y-intercept, I'm going to draw a graph so you can visualize. So this would be a vertical line at -1. Is this ever going to cross the y-axis? Would this line cross the y-axis? No. So the y-intercept is going to be none. For an A, doesn't exist. Not 0. Don't put 0, because that would mean it crosses that 0. So then 6 is just going to be the opposite. We have the y-intercept. Correct. We because it would never cross the x-axis. Okay. Any other questions on this page? I meant to do this in last class and I forgot, but we'll do it on the review.
We on this page?
Huh? On up to 10.
Oh, I was about to say 11.
11 and 12 is kind of what we were just doing at the beginning. Just finding where does this line cross the x and y axis.
What about 10?
We can do 10. Because 10 is going to be similar to what your delta math is, and you'll get a decimal, so sure. Okay, so let's do 10. Let's say we solve for x first. Solve for x first, put 0 in for y. Always put 0 in for the opposite.
Oh.
Always in for the opposite. So if I'm solving for this, this is going to become 0. So I don't really need to put that part. You can if you want, plus minus. But when I divide this, we're going to get a fraction. So on delta math, it's going to want you to leave it as an improper fraction. So you would leave it as this fraction, negative 25 over 4 cos 0. For me, if it were a nice decimal or fraction, like this one is,
What do you want us to?
you could leave it as a decimal for this one. For me, yes. Yes. If we went back and we solved for y now, but put 0 in for x, and we divided both sides by negative 5, what would y be?
That would be
5. So we would write it as,
that's 0.
there's one last thing that I want to show you, and that is on the back of this page, or the next page. Yeah, the back of this page. And then you'll have time to practice. You're still running. It's fine. Say that one more time. There may be one. Like one problem just like that. Okay. So in this section, where you're writing the equation of a line given the x and y intercepts, algebraically, you could find the slope of this and then you're given the y-intercept. Or you are given a graph. So I would plot these 2 points. Your x-intercept is at 3, 0. Your y-intercept is at 0, 2. If I have to write the equation, I need y equals mx plus b. So I could count my slope, which would be what? 3. It did go over 3, so that's going to be in the denominator. Negative 2. Yes. So if that's my slope, I have my y-intercept, I can put together my equation. Y equals negative 2 over 3x plus 2. Done. It is negative 2?
Yeah.
You count it down 2 and then over 3. So we plotted these 2 points and then counted the slope between us.
Oh, okay.
Okay. So I'm going to let you guys practice on delta math This one is formative. Do this delta math, and then afterwards you can be working on other missing delta math, retake work, test work, whatever. But do this first.